Okay, so we'll pick up where we left off, and I'm just going to now move into some other examples at a couple of different scales to talk about how people have been looking at the natural world, how natural resources are managed, and how that influences disease. This is a study that Lishka Remenkova, who's at UC Davis, has been involved with. It was again one of those things funded by the Ecology of Infectious Diseases program. This is an early paper from theirs out of this 2005 out of ecological applications where they're doing land use satellite imagery work in Belize, where they're looking at this that Anopheles vestipennis, which is a mosquito that carries malaria, and found that these mosquitoes preferentially favored phosphorus-rich wetlands, and that phosphorus-rich wetlands are being created by agricultural runoff. And so land use change patterns of increasing agricultural intensification were leading to increased malaria risk, with the idea that you could control malaria risk by controlling those ecosystem inputs. And so it's a case where people are looking at the ecology and resource management and human health. Again, a little bit like the Lyme disease case. But you have, and there's now been easily a decade of people looking at these kinds of issues. And this is a paper, I didn't write down what year this was, but it's not that old. But it's a very well cited paper by Dasek et al. Emerging Infectious Diseases of Wildlife, Threats to Biodiversity and Human Health. And they identify three different kind of cases or key major groups that result in general patterns of emerging infectious diseases. And there's one in that this is spillover from domestic animals to wildlife, and a good example of that is canine distemper leading to declines in wild dogs. And so you can see that as contact between humans and wildlife increases, and particularly dogs to wild dogs increases, then the risk to wild dogs goes up, since they're susceptible to these diseases as well. So there's that one kind of case where you're having domestic animals contacting wildlife. There's another one where emerging infectious diseases of wildlife that are directly related to human involvement. And one of the examples they use is herpes in elephants, where the African elephants have a herpes virus, and that it's relatively benign in African elephants, but because of contact between African and Asian elephants driven by human interventions, that's now in the Asian population of elephants, which apparently is very susceptible to the herpes virus. And so you have a lot of cases of managing wildlife that where if an animal is brought into captivity, it will not be allowed back out into the wild. So, for example, desert tortoises that are in captivity cannot go back out in the wild because of the worry of disease transmission, doing something like this second case where human involvement directly is a vector for this disease. And then there's a third case, which is emergence without overt human involvement, that one presumes in most of these cases there's been some sort of human involvement in the background, but it's considerably less direct. And an example that they use there is chytrid fungus emerging in these pristine sites. And so chytrid fungus seems to have moved out of wherever it was endemic, and probably through with human assistance, but then it's been able to spread around into a variety of populations without any direct human input since then. And so once again, it's helpful to think about connectivity and the movement of individuals across populations and the contact zones between humans and wildlife in terms of wildlife disease. And so in this review paper, they have this very kind of nice and I think informative diagram of thinking about a conceptual model that you have emerging infectious diseases of wildlife that's moved around within wildlife, that you have diseases within humans that are moved around within humans, you have them in domestic animals, and you have these interactions between all of these sets. And so, for example, we worry about bird flu moving from domestic chickens to humans, but we could also worry about canine distemper moving from domestic animals to wildlife, and that we can have a variety of different factors that increase the likelihood of these things happening. And as I said, there's been lots of people studying this, and it's become a rather big deal. So here's a paper from way back in 1996. Craig Packer's in this list of papers, of authors rather. This is the Serengeti of northern Tanzania and southern in Masai Mara in Kenya. And the diagram on the right-hand side is looking at the increase in seropositive lions for canine distemper. And so here we have the African lion is susceptible to canine distemper. And you see the size of the Serengeti study population in the upper graph crashing in the early 90s. And there may be multiple reasons for this, but it appears that disease is one of those reasons, as the fraction of the population that's been exposed to canine distemper becomes very high. It's up to 80% by 1994. And you see the feline mortality per year increases, so that young and vigorous animals can carry the disease, but it seems to be associated with mortality of older individuals. And I didn't go through this with enough care, but I'm guessing that what they're suggesting is that this is shortening the lives of these lions. Similarly, here's a paper from 2001 on spotted hyenas, regular exposure to rabies virus and lack of symptomatic disease in Serengeti spotted hyenas. And so you see spotted hyenas, well, they look like they're pretty robust to most anything that hits them. But again, you're getting 13% of individuals in this study area are testing positive for rabies, even higher proportions of bat-eared foxes and white-tailed mongooses. And so you have a pool of wild animals that are carrying this rabies virus around. And again, also you see this moving back and forth with domestic animals. And so once you move a disease that's principally known to domestic animals into a wild, it can then circulate in the pool in the wild. And this last slide here is just another paper, on this time looking at the social structure of primates and thinking about disease transmission. And this is a relatively recent paper. And there over here on the right-hand side in this table, glossary of terms, you see the SIRS model down there, the third box, susceptible, infected, recovered, removed, or resistant. So they're using a SIRS model to think about movement of disease through the population, and they're saying that the sociality or the social structure of these primates influences the disease susceptibility, and therefore we might be thinking about managing the population based on that social behavior. So, all right, anyway, I hope this is a helpful kind of introduction to the breadth of things that people are looking at with respect to diseases and conservation of wildlife and natural areas. And I look forward to Eric and Alicia's presentation tomorrow. That's it for tonight. Thanks.